So the second step which comes after classifying the data is how to represent the data. And we always represent the data on a certain graph. Okay, let's see what are the different types of graphs we can have for a given data. The first one is bar graph. Then we have, in the next part we have histograms. After that we have, after histograms we have frequency polygons. And after frequency polygons we have pie charts. So these are the 4 different types of graphical representation of data. Right? These are the 4 ways in which we can represent the data on a particular graph. So we'll discuss all these graphs one by one. I'll give you the textbook definitions of all these terms. So let's see the bar graph. Now guys, bar graph, just see the definitions once. It is a pictorial representation of data in which bars of uniform width are drawn with equal spacing. So this is the first type, which is bar graph. Now let's see the second type. The second type is histogram. So in the case of histogram, guys, see, histogram, this is a form of a bar graph only. This is a type of bar graph, but with continuous data. Let's see the third one, which is frequency polygon. And guys, note down the definition. The textbook definition is, here we join the upper midpoints of the rectangles in histograms. So these are the basic definitions. I will now tell you how to form or how to plot each of this diagram. Pie chart we'll discuss later. It is a bit out of the box or out of the context thing. We will discuss that later. The main statistics is based on all these 3 things. Okay. In the case of bar graph, let's suppose I have a data. I want to measure the pollution levels of the country. So what I can do is, the first way is that I can see the pollution levels of specific states or specific regions. Let's say first one is Delhi, then we have Mumbai, then we have, let's say, Chandigarh. So this is the first way I can see the pollution levels of certain areas or certain cities, right? The major cities, and I can describe this on a graph. Now this graph is definitely very vague graph. Chandigarh has the least pollution, so I will represent this data like this. So this Mumbai and Delhi, I will show like this, right? So Delhi, Mumbai and Chandigarh, let's suppose the graph is like this or like this. Okay, let's not go technical here. The basic understanding should be clear that we are plotting bars of uniform width. Now this width will be uniform. Now this Chandigarh cannot have more width. It needs to have the same width as these two. Now the width of all these rectangles will be uniform and they will have equal spacing between them. Now this is the pictorial form of representation of data. In this case, we are writing some names over here. Right? We are writing some names on the x-axis. While in the case of histogram, we will replace these names by numbers. Let's see how. Now if I want to see the pollution levels of the country in some time, let's say this is 2000, 2010, and let's say the probable pollution level of 2020, right? So let's suppose pollution from here to here, it's like this, and I'm predicting that pollution levels will rise to this, and from 2020 to 2030 the pollution levels will become this. So this is a probable estimation. Now see the difference between the bar graph and the histogram. In case of bar graph I was writing the name of the cities, but in this case I am writing some numerical data. This is a very important difference. In this case I am writing some names or some specific regions or some specific, let's say, months, right? So this can be a pictorial, this is a pictorial representation. This is not a continuous or numerical data. So this data is based on some specific names. But in this case I am writing some numerical values. Now the pollution levels from 2000 to 2010 will be this one. From 2010 to 2020 will be this one. And from 2020 to 2030 will be this one. So this is how we plot a histogram. In this case we always have a continuous data. In this case we need no gaps here. In the case of bar graphs we had some gaps, right? And we have some rectangles of some width, constant widths. But in this case I have no gaps. So this is a pretty much continuous data. Now let's see what I will get if I join the midpoints. So if you have noted down the histograms, I am going to do the frequency polygon on this one only, right? So don't mind. And we always use a kink here, which I will discuss later. Okay, let's get to that part later on. So let's see the frequency polygon now. We will join the upper midpoints of all the rectangles in the histograms, and we will join these. The thing which I will get is known as a frequency polygon. So this is the meaning of a frequency polygon. If we join the upper midpoints of all the rectangles of the histogram, I will get this thing. So let's see some questions. So I will go step by step. First of all, we will discuss bar graphs. The first question, guys, is, let's suppose this is the expenditure and this is the games. On the x-axis we are representing the games. Let's say this is cricket. I'm just writing, okay, I'll write the full one only. Cricket. Then we have football, right? Then we have, let's say, basketball. Then we have, let's say, volleyball. And let's say in the last we have, you can write anything. What is your favorite sport? You can write that. Let's write badminton. It's a very common sport and very easy one also. Okay, anyone can play that. So I'm going to make the expenditure, plot the expenditure on each of these sports on a graph form. So let's say the expenditure on cricket is 6. The expenditure on cricket is 6. This is 6, 4 and 2. The expenditure on football, let's say, is 3. So here it is 6. The expenditure on football is 3. The expenditure on basketball, let's say it is very less. This is 2 only. The expenditure on volleyball, let's say we're spending a lot on volleyball. We want to encourage volleyball here. And the expenditure on badminton, let's say this expenditure is coming out to be 4, because a lot of students play this sport. Now I am not giving you exact value of this expenditure. Just note it down. I have given you some random numbers for this expenditure. Now what I am going to ask you, if the total expenditure, just see the question, the typical type of questions which can be asked in the case of a bar graph. Okay, this is in the case of bar graph. As you can see, I am writing some names over here. And this is not a continuous graph. Therefore, this is a bar graph. Total expenditure, let's say it is equal to 2 lakhs. Total expenditure is equal to 2 lakhs. Now my question is, find the amount spent on the first one is cricket, and the second one is, let's say, badminton. Now guys, can you tell me how to find the amount spent on cricket and badminton? We know that cricket, we have 6 units. And can you tell me what is the total number of units? The total number of units is 9, 11 and 20. Right? So the total number of units here is equal to 20, and the units for cricket, they are equal to how much? 6 over here. Therefore, the amount spent on cricket, this is equal to 6 upon 20 into 2 lakhs. Right? So this is equal to 60,000 or 60k. So the amount spent on cricket, this is equal to 60k. And you can see that the amount spent on badminton, let's say this is equal to 4 upon 20 into 2 lakhs. So this amount will be equal to 40k. Right? So that's how we deal with the questions of bar graph. Right? Let's see one more problem. It is a pretty easy concept. You should not have any problem in the case of bar graphs. Now the other concept is how to plot a bar graph. This is a very easy one. Let's say the seats won by political parties are given. The first one is party A, B, C and D. Now plot a bar graph. This is a very easy one. I will do it quickly. Let's do it quickly and solve this one. So the bar graph will be plotted like this. Now these are the seats won by these political parties. This is the party A, this is the party B, this is the party C, and let's say this is the party D. And the seats, I'm writing like this on a scale of 10. So the first party has 10 seats. The first A party has won 20 seats over here. And the second party has won how many seats? 30 seats. So this rectangle will be raised to 30. Third party has 15 seats, so this, and the fourth party has 10 seats, so this. So this is how we plot a bar graph. This is how the formation of a bar graph is done. Now let's see the next concept, which is histogram. Now this is more important, but I wanted you to get a nice grasp on the bar graph before we start with histograms. Because if you're not clear with bar graphs, you cannot move on to histograms. So let's see what is a histogram. In the case of histogram, I already told you this is a continuous data and this is also a form of a bar graph only. But this is for a continuous frequency distribution. So this is the first property of a histogram. The second property is that the width is directly proportional to, now the symbol of proportional to is like this. Width is proportional to the class size. Now what is this width? This width is the width of a rectangle. Now in the case of bar graph, we had uniform width rectangles. Now in this case, the width will be proportional to the class size. And the second thing is height or area of rectangle is proportional to frequency. Now why did I write two things, height and area? You will understand. I will make you understand. So just note down this definition. First of all, let's get into the details now. So the width is proportional to the class size and the height or the area of rectangles is proportional to the frequency. Let's start with a very simple one. This is a type 1. In this case, the standard data is given like this. Let's say 140 to 150, 150 to 160, 160 to 170, and 170 to 180. We have the frequencies as 5, 10, 20 and 50. Now plot the histogram here. This is very easy concept, but the thing which you need to remember is you cannot just move on to 140 just like that. You have to put a kink over here. So this is the basic thing which I want to teach you from this question. So let's go step by step. First of all, you need to know the significance of kink. You cannot move on from one 0 to 140 by making 14 equal intervals and then put 140 to 150. You have to put a kink over here so that all this clumsy data can be arranged easily. So 140 to 150 first, then 160, 170 and 180. So 5, 10, 15, 20, right? So the first one has 5, the second one has, now see there is no gap. In the case of bar graph we used to have some gaps, but in this case this is a continuous data. This rectangle will start from here, and in the third case the rectangle will start from here. This is 20, and in the fourth case this is 15. So this data is continuous, right? So this is the first type in which the data is in the standard form. Now if we remember the case of basic statistics, in that I told you that sometimes we need to adjust the class intervals. Now we'll see the case when we need to adjust the class intervals. So first, let's suppose the data is given like this: 0 to 9, 10 to 19, 20 to 29, 30 to 39, and the frequencies are same: 5, 10, 20 and 15, right? So in this case, the histogram which we'll try to make, this will become like this. Like the first one is 9, then we have 10, then 19 we have 20, then 29 we have 30, then 39, and then we will be having 40. So in this case, the first frequency is 5, then we have 10, then we have 20, and then we have 15. Now guys, see, this is not at all a continuous data, right? Now this is not the correct histogram because this is not continuous. So what we'll try to do is first try to make it as continuous class intervals. How will we make that? First, I will write 0 to 9.5, then 9.5 to, let's say, 19.5, then 19.5 to 29.5, 29.5 to 39.5. Then this will become a continuous data. Then the intervals will be 9.5 here, 19.5, 29.5, 39.5, right? Then this will become a continuous diagram, right? So this is a corrected histogram, and this will be the final histogram which I am getting. So you need to understand what will be the corrected histogram, how will I get the final form of the histograms, right? And let's see the third type. The third type is where we need to adjust the frequencies. So we will see the third type where we need to adjust the frequency, and that will explain you this point which I laid emphasis on, that the height or the area of rectangle is given by the area of rectangle is given by the frequency, right? Now in the case of adjusting frequency, I will take example. So let's suppose the marks obtained by students are 0 to 20, 20 to 30, 30 to 50, and then we have 50 to 80. In this case we have 7 students, 15 students, 20 students, and again 15 students. Now guys, see, the first class interval has a width of 20, the second class interval has a width of 10, the third class interval has a width of 20 again, and the last class interval has a width of 80. And the frequencies are 5, 10, this one is 15. Now guys, see, in this case, these class intervals are not regular. So if I say that from 0 to 20 I have 7 frequency, the frequency is 7. Now this is distributed from 0 to 20. Now these, guys, pay attention over here. These are not bar graphs. In the case of bar graphs, we have equal width. Then the height will denote the frequency. But in this case, the whole area of this rectangle will give you the frequency. So in this case, you can see that from 0 to 20, I have 2 small intervals, right? So the first class interval is just of 10 class width. So the class width of this first class interval is 10, second class interval is 10. For this is 20. For this is again 20. For this is 30. So in this case, this 15 is distributed only amongst this 10. But in this case, this 7 is distributed in the class width of 20. So in this case, the first case, I have to divide this into 2 equal parts. I explained you this, how to adjust the class center of frequencies. So in this case, the second one will be as it is. So the second one will give you 15 only. But in this case, you have to divide it into 2 equal parts. So the 2 equal parts will be 3.5 and 3.5. And from 30 to 50, I am having 20. So this will be divided into 2 equal parts, which will be 10 and 10. These are divided into 3.5 and 3.5. And this will be divided into 3 equal parts, which are 5, 5 and 5. So the correct histogram for this case will be like this, right? So pay attention over here. In this case, the area is proportional to the frequency. So if you see the area of this one, this will give you, so let's try to find out the area. This is, let's say this is 2 units, this is 1 unit, this is 2 unit, and this is 3 units, right? So the area of this one will be 7, because 3.5 into 2 is equal to 7, and that is giving me the frequency, right? The area of this will be 1 into 15, which is giving me this frequency. The area of